recap for the video. What have we done so far? We created our table of values. Oh, and it says we didn't even read the question. What did I not read for the question? All the way up to 8 bags. So this is good that we're reviewing things here. So we only went up to 3. 4 would be 40. 5 would be 50. 6? Yes. Yes. Awesome. We have to go up to 8. No. It just says create the table going 1 through 8 bags. I guess we didn't need 0, but I like the story of starting off with 0 because, hey, do we remember what the 0 stood for? The y-intercept. Okay. Oh, it caught. I heard a comedian. Oh, he was really good. I'll show you him later. You'll enjoy it. Okay. Kind of like flip. Okay. So, we need to decide what kind of scale we want to do. Okay? Our money is going up by tens. So I'm not going to say 1, 2, 3, 4, 5, 6, 7, because I'm going to be like, it's going to use your whole graph. So along my y, I'm going to go each one by 10, 10, 20, 30, 40, 50, 60, 70, 80. And on my bags, they go by 1, so this makes sense to go 1, 2, 3, 4. Okay? My numbers would be so small on here. So now we can label these points: 1 bag, $10, 2 bags, $20, 3 bags, 30, 4, 40, 5, 50, 6, 60, 7, 70, 8, 80. It's making a nice straight line. Okay? And sometimes, like I drew a line through it. Okay? Sometimes it's going to make sense to draw a line through it. Sometimes it's not. You might argue in this sense it doesn't. Would your dad pay you $5 if you did half a bag? Maybe. It might be if that was the last bag and that was all that's left and it's a half a bag, right? So if you got paid for half bags or a quarter bag, or if the last bag was 1/10 and you'd be like, can I get $1 for the last bag? Then the line makes sense. But sometimes the line doesn't make sense because you don't get paid for half things, right? I'm selling shoes. Every time I sell a pair of shoes, I make $10, right? No one's going to buy half a shoe. So in those cases, you would just leave the dots and not have the line. Yeah. Okay. Ooh, we decided on, let's change this because we decided for money and M, so we can just change the question. B for bags, M for money. What's our equation? Money is going to equal 10 times however many bags you have. There's your equation. How much would you earn if you did 5.5 bags? Now that we have the formula, we can plug in 5.5 for the bags. And what's 10 times 5.5? You would make $55. If you raked all day and did 12 bags, $120. That would be that'd be nice. I'd be happy if someone gave me $120 right now. Okay. Example 1, fairly straightforward. Why? Because it was every bag. Okay. Example 2, a little bit more complicated. A family to attend an amusement park, they must pay a flat rate of $20 plus $5 per person. So this would probably be, sometimes they have this when you go to a place, they have different prices for different things. So for example, if you went to as an individual to this, they might say it's $15 a person. But if you have a family, you pay $20 plus $5 per person. So even a family of 2 would be a better deal, right? Because it would be $25 rather than $30. And then the more family members you have, you would pick the family deal. So I think if you go to the zoo in Winnipeg, they have something like that. You're like, ooh, is it better to do the family, or is it better to? So I'm going to get you to try this one on your own, and I'm going to put up the answer in a bit. Here we go. So you've had a chance to work on it. Boom. How did your table go? Did it look like that? Now, you would put the number of people in the first column because that's the dependent, or independent, sorry. That's why I put an I there. We always put our independent, what we can control, first. Then, the dependent is how much it's going to cost. So you can check your numbers there. I went all the way up, one by one, up to 8, and then I skipped and went to 10. So what is the independent variable? The number of people. What is the dependent variable? The cost. Question C, create a graph from your table. So now you have to come up of, you make sure people is down here, label that, cost is here, and you have to decide what each of your graph grids on your paper. I decided to go by 5s. You might have gone by 10s. Either is fine. What you cannot do ever is decide to go by different numbers. So you can't say, oh, I'm going to go 0 here, then 20, then 25, 30, 30. You can't jump by 20. As soon as you jump by 20, then every jump has to be 20. So you have to keep things stable. There are some tricks in graphs. Sometimes you have a graph that you want to show, like, year 2000, 2001, 2002, and you can do something like this. Because if I put a little break in the graph, because otherwise be like, well, it's annoying to graph from 0 up to 2000, a whole bunch of nothingness. So we see that sometimes in a graph. Okay? But in our examples here, we don't need to have any breaks in our graph. We might have breaks in our eraser. Oh. So 0 to 9, 5 to 50 is what I did, and I plotted my points. It made a nice straight line. What is the y-intercept? At 20. What would that be if no people came but still paid for the family rate? We'd like to pay for the family rate, but no one's going in. Okay, that'll be $20. Smart family. Yes. Yeah. Okay. Did you get a formula? Did you see that you're going up by 5 each time? So that's where that 5p was. But you had to pay, or your y-intercept would be 20 if nobody went. So it's 5p plus 20. And then, how much would a family of 5 have to pay? You'd plug in 5 for the P. Multiply things out, get 45. Would you have to use the formula? Probably not if you did the table of values and it was in your table of values, okay? So sometimes you have a shortcut, like I've already have this answer. I know it's 45, right? But if you wanted to use the formula, right, all of a sudden, 3 buses come up, and there's the family of 32. Wow. Didn't they have a show? Probably had some reality TV show with this family with like 20 kids. Yeah.
There's a student here with a family of 11 kids.
Look at that. So.
Probably sharing a room with like 4.
Just keep pushing out. Just keep pushing out babies. Yeah, I'm sure it. Okay. Have you seen Monty Python Meaning of Life? Because there's at the beginning of that one, there is a family that has many kids, and she's just standing at the laundry machine doing laundry, and a baby just falls out. Oh, could you get that, dear? Anyways. All right. What about a large group of 20 people? Only, or a large family of 20 people, only $120. Pretty good cost per person, right? But I'm pretty sure that if you have a family of 20, your life is pretty expensive. Okay, this one's kind of neat. Restaurant charges $2 for a pop with free refills. What's your table? What are you in control? Right? This is number of refills. Okay? What letter do we want to use for refills? R. Love it. And cost. C. Okay. You don't get any refills. How much does it cost you? $2. Well, you still buy the drink. You just haven't got any refills. All right? Get your first refill. All right? Okay, first refill, how much is it going to cost? $2, right? Diagram of the bladder here. Second refill. $2. Diagram of your bladder. Third one. How many? Oh, we have to go up to $2. Diagram of the bladder. Okay. It says we have to do 4. How much is 4 going to cost? $2. Diagram of the bladder. What about 10? $2. Bladder, you probably have gone to, I don't know. Or it's exploded. Okay. No, I think bladders can. There was a famous scientist / mathematician. Well, famous, notorious maybe. He was pretty good at math that he got recognized, but he was more well known for other things that happened to him. For example, he had no nose. He lost his nose in a sword fight duel. So he had no nose, and he died at a party because he had too many refills of wine, but felt it would be inappropriate to leave the table to go to the washroom, and his bladder burst. And that's how he died. So he did do some famous math stuff, but also more known for losing his nose and dying from an exploded bladder and drinking too much wine. So, maybe. So, The moral of the story is if you have to go to the washroom, you should probably go. Does it hurt to die? I'm sure it doesn't feel good. Okay? So here's our graph. Our independent is refills. And our dependent is the cost. Because we put refills in our x. Okay? I'm going to go 1, 2, 3, 4, 5, 6. And the cost, 1, 2. What does the graph look like? It just stays at $2. Right?
No matter how far you go, it just keeps going.
Mm-hmm.
It's just +2.
Why am I choosing yellow? You can figure that out. I drew another graph. What am I putting on this side? Bladder. Does it make sense that it would be going up?
Yes, it is.
Hopefully sometime in here you go back to 0. And then it would probably keep going up.
I feel like that works.
What's the formula?
Cost equals 2?
Cost equals 2. Sometimes, yeah, we'll just leave it like that. All good. So, there is some, oh, we got one more example, sorry.
That's what I thought. I was like, it's just cost.
This is fun times. We've got a graph, and we need to create a story. So we need to come up with an independent variable.
Great.
Your math grade is math grade. Math grade here. And down here, dollars paid to Mr. Shirk. Right? You control how much dollars you pay to Mr. Shirk.
Actually, we're actually doing that.
Why not?
It's the lesson, yes.
Okay, this is a lesson. Okay, we're gonna make our scale here. Let's say it's starting at 50 here. Okay, and your math grade after paying Mr. Shirk no dollars is sitting at 50. Okay, we're gonna add 2 points on here. Okay. This one is going to scale, according to the scale, this looks like, what is that, maybe goes up to 70 here, right? 60 here in the middle, right? You pay Mr. Shirk $10,000. You raise your mark 10%. You pay Mr. Shirk $20,000. You can raise it up to 70. Yeah. So you have to figure out if this is worth it or not, right? Change your life kind of money. Do you know, right? After paying Mr. Shirk $0, you get 1 grade 9 math credit. But after paying him $20,000, you also get 1 grade 9 math credit. Right? But students with a 70 get a scholarship for $12 for next year. So you might be worth the 20 grand.
I'd have to go up more. You can walk home with that nice ride your parents will have. Usually a nice gift. You've worked so hard. Here's
$12 scholarships.
Maybe a couple, maybe 4, 5, maybe 6. How's your DQ?
All right. So these are sometimes kind of fun because you can make up a story that matches it.
It's hard to figure out
Mm.
You did, that was quite easy though. I was like, how are you gonna work this with grades when it starts at?
At 50. Well, your grade is this now. You haven't paid Mr. Shirk any.